Assalamualaikum warahmatullahi wabarakatuh. My name is Mama Afiq bin RAHAIZAN and my metric number is 2010909991. I'm from Group 1A. Today I will present open-ended lab 3, which is DC machines. For the introductions, direct current DC motors are used to convert electrical energy from direct current to mechanical energy. Permanent magnet DC motors, PMDC motor, independently excited DC motors and self-excited DC motors are three different types of DC motors. Series DC motors are a class of self-excited DC motors which the field coil is connected in series to the armature winding and thus a higher current passes through it. A winding field DC motor are known as a shunt motor, use electromagnetics to produce magnetic field flux. There is a parallel connection between the armature winding and field winding. So we have three motor, which is DC series motor, DC separately excited motor, and DC shunt motor. For the procedure that we do the experiment in lab, which is connection and motor direction control, torque speed characteristic, speed control for DC series motor, speed control for DC shunt motor, and DC separately excited motor. Result and analysis. For connection and motor direction controls, for the standards we get DC power supply 25 VDC, but for the reverse connection leads of A1 and A2 terminal we get 25 VDC. So the direction of rotation, we can see the rotation is clockwise for the standard and for reverse is anti-clockwise. For torque speed characteristic, for my team we fix the voltage motor, which is we use 110 volts. So we can see for the current motor we get increase the value from 0.9 until 1.96, but for the speed motor the result we get is the value is decreasing, which is from 1190 until 558. So for the graph for my team we use 110 volt. So this is we get two graph, which is one of them is speed torque characteristic curve. We can see the graph is the T is decrease linearly with speed, but for the current torque characteristic we can see the graph is increased linearly to the current. For the analysis from table, we had observed characteristic of the torque speed in DC series motor. The DC power supply was set in constant value, which is 120 VDC, and the output torque that being given to the system is start with 0.02 kg per meter and increase until 0.16 kg per meter. From the procedure, the motor speed N, which is obtained from the brake controller, the motor current I that obtained from digital DC ammeter, and the motor voltage E that obtained from the digital DC meter were recorded in table. From the result, the speed is inversely proportional to the torque. The higher value of the speed, the value of the torque will be decreased. It can see from the figure, which is the graph speed versus torque. Then the current is directly proportional to the torque. The higher value of the torque, the value of the current also increase. It can be seen from figure, graph currents versus torque. This is speed control. From the table, my group use 110 for the voltage motor. So we can see the current is decreased from 1.66 until 1.05. For field current, also decrease the value, which is from start 1.37 until 1.09. And for the motor speed, the value we get is increasing from 762 to 834. So for my team, we use 110. This is the two graph that we get. One of them is speed resistance. We can see the graph first increase until 990 rpm, but then the graph will decrease linearly until 910, and again increase a little bit to 920. For the current resistance curve, the graph first increase until 1.9 ampere, but then the graph start decrease linearly until 1.6 ampere, and again increase and decrease and increase again to 1.62 ammeter. So from the result analysis from table, we had done observe the speed control of DC6 motor. The DC power supply was set in constant value, which is 120 VC, and the output torque that be given to the system is constant, which is 0.1 kilogram per meter. On the DC motor field regulator, the knob was set up to 47 ohm position at the first and decreased until 12 ohm positions. From the procedure, the motor speed and which obtained from the brake controller, the motor current I that obtained from the digital DC emitter, and motor voltage E that obtained from the digital DC emitter were recorded in table. From the result, the speed is inversely proportional to the resistance. The higher value of the speed, the value and resistance will be decreased. You can see from the figure, which is the graph speed versus resistance. Then the current is inversely proportional to the resistance. The higher value of the resistance, the lower the value of the current. For this is shunt motor, we fix the speed, which is we use 1500. So we get for the armature current, the result is increased value from 0.22 until 0.53. For the field currents, the value is decreased from 0.11 until 0.02. And for the voltage motor, you can see the value is decreased also from 159 to 57. So the graph voltage terminal versus field current, you can see the graph is a little bit like increase linearly proportional to from VT to IF. From table, we have see the speed control decision motor was set in constant value, which is 1770 rpm. The output torque that is given to the system is constant, which is 0.05 kilogram per meter. And for DC motor field regulator, the ohm knob was set up to 0 ohm position at the first and increased until 1500 position. From the procedure, the motor speed and which obtained from the brake controller and the motor current that obtained from the digital DC emitter and the motor voltage obtained from digital DC emitter were recorded in table, and result the speed is steady constant followed to the resistance. The higher value of the resistance, the value of the speed still constant. It happened because we had set the motor speed at constant value 1770 rpm only. You can see from the figure, which is graph speed versus resistance, the current is direct proportional to the resistance. The higher value of the resistance, the higher value of the current, and it can be seen from the figure 13 graph current versus resistance. So the discussion of This lab for connection and motor direction control, we had to demonstrate the connection of a DC series and control the rotation direction of the motors. From the segment, we can demonstrate the rotational direction of DC motors can be changed by reversing the path of the motor's torque. For torque speed characteristic, also for this experiment, the characteristic of the torque speed DC motor was observed like the voltage, current value, speed of the DC motors. Based on the result that have been obtained from the experiment, this three table shows us when we set up the different value of the motor voltage, we can see the changing of value in each part such as the current, motor speed, while the output torque was set 0.02 kg per meter. The value of the current for all three tables shows an increasing trend. This is because when the value of the output torque increase, the current will increase, causing the value of the motor speed to decrease. For speed control, the speed control of DC motor will observe like motor voltage, current, value of the speed, knob, and field current. And based on the result, we obtain the table for 110 volt motor voltage that we fix. The value shows for the current value increase, but the current the value decreasing when they adjust the knob from high values, which is start from 47 ohm down to 12 ohm. And the value of for table 110 and 120 volt, same result, which is the value shows us the current, the value increase, but field current, the value decreasing when we adjust the knob from high value, which is start from 47 down to 12 ohm. For the speed motor, the value increases. And last, DC shunts. The magnetizing curve of a DC shunt motor shows the relationship at constant speed between the no-load terminal voltage and field current. In this experiment, three magnetization curve for three speed, which is 1500 rpm, 1600 rpm, and 1770 was observed. Plot the magnetizing curve number at various speed reveal that the curve for the gateway excitation will change directly with speed, where can be shown magnetizing curve from figure. The higher speed will increase the terminal voltage. So lastly, for the conclusion, we are able to demonstrate connection of DC series, DC shunt, mount motor, and control the direction of rotation of the motors. We had understand the limitation parameters and demonstrate the torque speed characteristic of DC series and shunt wound motor. We are able to understand the control and speed limitation of DC series and shunt wound motor. Overall, the experiment objective were accomplished successful. So that's all for me. Thank you.